Okay, so this one is just an acid-base question. So what is the pH of 0.390 molar ammonia? So first off, we need the Kb for ammonia, which comes out to be, I should at least write it out. So Kb ammonia is 1.8 times 10 to the minus 5. Okay, so our ammonia is going to combine with water to give us, so our H plus is going to transfer this way to give us NH4 plus OH minus. Now we can make our ice table. So we have 0.390 and nothing of these initially. Our change is going to be minus x plus x plus x. And that's just because we're in a 1:1:1 mole ratio. And so at equilibrium, we're going to have 0.390 minus x, x, and x. So we can write our equilibrium expression as our products over our reactant. Remembering that pure substances like water are not included. And so this is just x, x, and 0.390 minus x. And now I'm going to make a simplifying assumption that because Kb is 1.8 times 10 to the minus 5, that our x is probably very small, and so this is approximately 0.390. And so this will just save us from having to use quadratic equation. And so our x squared is 1.8 times 10 to the minus 5 times 0.390, which is 7.02 times 10 to the minus 6. So x is 2.65 times 10 to the minus 3. And we can see the validity of this assumption, because 0.39 minus this is approximately 0.39, I would say. Okay, so now this is our OH minus concentration, but we're asked for pH, which is the negative logarithm of the H plus or H3O plus concentration. So to move this to H3O plus, we can use a few means. The one I'm going to use here is just that our water ionization scheme looks like this, right? And so Kw is a constant, 1 times 10 to the minus 14. And if we look at what we have here, and I shouldn't have put these square brackets in, I carried away. If we look at this expression, products, so it's just going to be the product of our H2O plus and our OH minus concentration. And we know our OH minus concentration, so we can solve for our H3O plus concentration. And so our H3O plus is just 1 times 10 to the minus 14 over our OH minus, which comes out to be 3.77 times 10 to the minus 12. Units with equilibrium stuff is wonky, so I'm just going to add it in whenever we know it, which would be there. And so then pH is the negative logarithm of our H3O plus concentration, which is the negative logarithm of 3.77 times 10 to the minus 12, which is 11.42. Okay, so there's our pH. All right, so we need our Kb for ammonia. We use our ice table, solve for, so they did use the quadratic equation. So it comes out to be 2.64 times 10 to the minus 3. I got 2.65, so that's possibly just, that's possibly rounding errors, but it's also possibly due to that assumption I made. And now, so now we can either use the method I use to swap to the H3O plus concentration, or you can go directly to pH by first finding your pOH, and then using that the sum of the two must be 14, which is what they used here in step 5, and then you get that your pH is 11.42, which is exactly what we found here. So this looks good and shows kind of a different method.